Hey everybody, welcome to the Tech Chat with MenTech. In this series, we're going to give you, a deep dive into some tech topics that you can use in deciding your career choice and your career path that'll help you land the next job. So, I'm Rashad Russell, founder of Beyond Light Creations software consultancy. Today, we're going to be talking about scaling the back end of your online applications. So I collected a few tips and tricks that I thought were pretty cool that you can use to help apply to your application as the number of users growing your application. So so first things first, it's common advice when you're thinking about high scalability applications. When applications begin to grow to 100,000, a million users, million plus users. How do you handle that type of scale? And one of the common pieces of advice is to not over optimize your system too far ahead of time, because that's added complexity. However, I think it's pretty important to at least understand some of the tools out there that can help with this, and to at least have a plan in place to consider what your next steps would be as your system begins to reach capacity, so you can prevent yourself from system failure. So we're going to jump in. I have 9 tips and tricks I want to share with you guys. So the first tip number 1 is make sure your database is configured for production. And this really applies to any system that you're working on. Any system that you decide to add to your tech stack is to make sure it's configured properly for production. And particularly your database being one of the most highly requested, highly hit services in your tech stack, it needs to be configured properly. You can check, for instance, in MySQL, they have in their documentation a list of things you can do to fine tune your database. It's not too many, it's maybe only 1 or 2 configuration pieces that need to be done. But whatever database you're using, MySQL, Postgres, MongoDB, check that documentation. But if you're using, most likely if you're using a cloud hosting provider such as AWS or Heroku, a platform as a service host, most likely it's just a 1 or 2 click configuration where they ought to do that for you. But as a software engineer, if you're just curious how things work underneath the hood, check out your database's documentations about performance tuning. So tip number 2, move your database to a separate server. It's generally a good idea to do that, to separate your database server away from your application server. Your database, like I said, your database is one of the most highly hit pieces in your tech stack, so it's subject to the most load. And per recommendation from say MySQL, when you're configuring your database for production, it actually suggests that you should reserve 80% of your system's resources and memory for your database. So if it's consuming that much memory, that doesn't leave a lot of space for your application server, and then your operating system needs space to run tasks behind the scenes as well. So it's generally a good idea to have your database early on separated on its own server, so it can have a full system to utilize the system's resources. Step 3, and this kind of goes along the line with the last step, is to move any CPU intensive operations to its separate server away from your application server. So you think about applications like YouTube or Instagram. Like YouTube, you upload a video. Videos are very big files, but when you upload a YouTube video, YouTube does a lot of pre-processing on that data. Like it needs to compress it, change the file format, add captions like subtitles, add advertisements. Same thing with Instagram. You upload a photo, upload a profile photo, it makes duplicate copies of that photo, adds a bunch of filters to that photo, and those are CPU intensive operations. So, and they take up a lot of memory. in space. So you don't want that competing with the resources on your application server. Just in case anything crashes, at least your online application can still stay online. So move that to a separate server. Step 4, consider moving some tasks offline. So when I say offline, I mean operations in your system that are not triggered by a user action or user activity. For instance, think about Google, how Google updates its Google rankings and Google search. Google sends off a web crawler that runs in the background periodically, maybe every so many hours, maybe a couple of days, and then you don't receive any updates on Google page rankings for any given query. Like, it could take up to 3 days. So these operations take a long time, so they need to be done offline. Same thing if you use Reddit or Hacker News. They have like leaderboards or rankings on posts, which posts are most relevant. These type of updates are happening offline every hour, every 3 hours or so. So step 5, which I think is pretty cool, is consider multi-column indexing. So as a software engineer, you probably already heard about indexing data in the database to help you if you have a million entries in your database, whatever that may be. Let's say it's an e-commerce site, you have a million, your inventory is large. When users search for a particular t-shirt or dress or jeans or something, the database, it would be pretty expensive to scan through the entire database. That'll take a long time if you have a million entries. But if with proper indexing, you can, make performance improvements up to like 50% or more. You can only scan half the database instead of the entire database for whatever data you need. And multi-column indexing is you can not only index one column in your database. Say if the user search based on t-shirt size, I want extra large. You can also group indexes like according to t-shirt size as well as color. And instead of scanning a million entries in your database, you may only need to scan 100,000. And as you potentially grow the index, you can reduce the amount of operations even lower, and that leads to a faster service, a faster response. So, and order does matter in multi-column indexing. Moving on, step 6 or tip 6 is disk-based stores versus in-memory stores. Consider, and I mean data stores, consider adding in-memory data stores because typical traditional disk-based stores such as MySQL, Postgres, MongoDB, it stores its information and data on the file system on disk, and that's a pretty slow operation to read and find that data versus something like Redis or Memcache, which are in-memory stores. That data is already loaded. The file system doesn't need to scan for those resources. It's already loaded in memory and it's given to you. And so consider in-memory data stores. Do some digging on that. Step 7 is replace aggregation queries with aggregation tables. So if you ever notice on social media, you see a long list of posts on your wall, and near the post there's some stats like the number of views, the number of reactions and likes, the number of comments made. More than likely, whenever you load Instagram or Facebook, Twitter, those stats, those type of stats are not being calculated in real time as you ask for it because they're pretty expensive. For sites like that with millions, up to 1 billion users, you're not scanning billions of rows of data to, calculate that. More than likely, they have a separate table, and over time, maybe every 30 seconds, maybe every hour, they're updating that. You can notice that on YouTube as well. Like YouTube doesn't automatically update that counter every time when you visit that view. It's being updated, say, every 30 seconds or so. So tip number 8 is add a caching layer to your tech stack. Caching is a general purpose computer science concept that's used all across the tech stack, from down at the operating system level. It can be done at the front end level, even on the back end level. Caching is when you think about scaling high scalability and scaling applications, online applications. caching is one of the go-to mechanisms for doing that. In general, caching, all that means is anytime you do, it's reducing the need or the redundancy to request data and resources that's already been calculated. So if one user asks for, let's say a Netflix video, large file, a new movie they want to watch, Netflix most likely cached that video, and so anyone that comes behind them requests that same video, the backend server doesn't need to query the database to try to find that video. It's already loaded, preloaded, because someone asked for it before. And Redis and Memcache is typical caching servers. And step 9, the last thing is load balancing. So whenever if you buy a book or anything and start reading, doing your research on building high scalability application, load balancing is, one of the first things that's mentioned. So as your application, your website, your mobile app starts to get to, 10,000 monthly views, 100,000 monthly views, or daily views, millions of users, a single server can't handle that many requests at one given time. So what load balancing does is it takes your application server, replicates it to however many you need, 10 servers, 100 servers, and every time a new user comes and requests information from your application, your website, your mobile app, a load balancer distributes those requests across those different servers. So one server is not being hit and being backed up. So and Nginx is a good load balancing server. They have an open source version. HA Proxy is another. And like I said earlier, if you're using a cloud hosting provider, more than likely they have a load balancing setup, or at least you just have to do like one click to configure it. But if you're just curious how things work underneath the hood, you can check out some of those tools, Nginx and HA Proxy, on how to set up a load balancer. So that's all 9 tips. We flew through that. Try to get it done early. And so like I said, these tips for how to build online applications that's highly scalable. This is not a complete list. There's like hundreds of different ways, and depending on your system, depending on type of application, whether you're building a multimedia site, you're building an e-commerce platform, a social media site, you have to think about, there's different set of concerns that you're dealing with when it comes to high scalability. So you can't just find one silver bullet to fix all problems. So with that being said,
thank you for watching. You can find out more about Mentech Agency at mentechagency.com.